Today we're going to take a look at concentrations of solutions and how we calculate the concentration of a solution. So there's two important vocabulary terms, dilute and concentrated. Dilute means you have a small amount of solute per a given solvent. And so your molarity, which is how we measure concentration, would have a low value. And that is like the picture on the left. Concentrated, you have a large amount of solute in that given solvent. So you would have a high molarity, and that's an example of the picture on the right. To calculate molarity, we do moles of solute per liter of solution. Now this formula is given to you on page 3 of your reference table, so you have it. The units are this capital M, which represents molarity, or you could write it as moles per liter, or you can write it as a fraction, or you might see it written as moles per decimeters cubed. Decimeters cubed is the same thing as a liter. So when you're looking at the problem, if the problem gives you grams, you want to take those grams and convert it to moles. If the problem gives you milliliters, you want to use King Henry died unusually drinking chocolate milk to go from milliliters to liters. And then the probably harder problem would be if you were asked to find grams. And in that case, you would solve for moles and then convert to grams. So just like the ideal gas law problems, molarity problems tend to have you do two things, either converting items at the beginning and then using the formula, or using the formula and then converting at the end. All right, so let's work through 3 examples. In our first example, we're looking for molarity. So right away, I know that I'm solving for M. We have 37.94 grams of potassium hydroxide. And I know that when I'm given grams, I need to convert those grams to moles. But before I can do that, I need to know what potassium hydroxide is. So we're going to cross our charges. Potassium is K, and I'm writing this in the upper left corner here, is K plus 1 because it's in group 1. Hydroxide is our polyatomic, and we put all of our letters and our subscripts inside the parentheses and then the charge on the outside. And then we're going to cross our charges. And when we cross our charges, we get KOH. So now we can do our converting. We can take our grams, bring grams to the bottom. We're trying to go to moles on the top. So molar mass, potassium plus oxygen plus hydrogen, is the number you would write with grams. And then 1 goes with moles. The grams would cancel out, leaving us with 0.6762 moles of KOH. Then we're given 500 milliliters. And I know that when we're given milliliters, we need to convert that to liters. So we use King Henry died unusually drinking chocolate milk. Right now we're at the M for milliliters, and we're trying to get to liters, which is the base unit. So we're going to move our decimal once, twice, 3 times to the left. So 500 becomes 0.500 liters. Then I look on page 3 of my reference table. I see that molarity is equal to moles of solute per liter of solution. And I just plug in my numbers, moles on top, liters on the bottom, and we get an answer of 1.35. We have 3 significant figures because our volume had 3 significant figures, which is less than the 4 given to us in moles. So the unit can be written as moles over liters, or you can simply say it's 1.35 big M, which stands for molar, or molarity. So this is 1.35 molar. Let's look at another example. Here we are given 750 milliliters. I know that when I'm given milliliters, I need to convert to liters. So King Henry died unusually drinking chocolate milk. We're going from the M for milliliters to U for liters. So that's 3 places to the left. So that gives us 0.7500 liters. Then we have 6.00 M. The M stands for molarity. That's a big capital M. Now, a lot of students confuse that and want to say that it's moles, but it's not moles, it's molarity. We are looking for the mass of sodium hydroxide. And when we're looking for mass, we're going to solve for moles, and then we're going to convert. So we set up our formula. We have our molarity, and that's equal to moles, which is what we're looking for, divided by liters. So to find or solve for X, we would multiply both sides by our volume. And so X ends up being 4.5. Now let me show you what's happening with the units. Remember, molarity is the same thing as moles over liters. So when we multiply by liters, the liters cancel, leaving us with moles. So the 4.50 is your moles. So again, when we're looking for grams, we solve for moles and then we convert. So now we're going to set up our table. We start with our given. We pull that to the bottom, and then we put grams on top. The problem is telling us that this is sodium hydroxide. So that's how I know it's NaOH. And we just need to plug in the numbers. So 1 goes with mole, and then sodium plus oxygen plus hydrogen goes on the top, and we multiply and divide. Moles will cancel, leaving us with grams, and we get 180 grams of sodium hydroxide. Now I have a decimal after the 0 to make it significant because I needed 3 significant figures. Okay, one more of these problems. All right, we're looking for molarity again, so we're going to solve for that big M. They gave us 390 grams, so we're going to convert grams to moles. So we pull grams to the bottom, we put moles on the top. We add acetic acid together, hydrogen, 2 carbons, 3 more hydrogens, 2 oxygens. We get 60.052, and then 1 goes with mole. Multiply and divide. Grams cancels, giving us 6.49 moles. Then we're given 1,000 milliliters. So we're going to use King Henry, died and usually drinking chocolate milk, to go from milliliters to liters. That's 3 places to the left, so we get 1 liter. Looking at page 3 of our reference table, we know that moles divided by liters gives us molarity, so we're just going to divide, and our molarity is 6.49. So you could write it as moles over liter, or you could say 6.49 molar. So that's one type of math problem here. The second type of math problem that we have is if we are trying to dilute our solution, which means we're going to change the concentration. So dilution, you're adding more water and bringing that amount of solute down compared to the amount of solvent. So you're increasing your solvent. Dilution. And so our formula is M1V1 equals M2V2. We know it's a dilution problem as opposed to the molarity problems we were just doing because you're going to be given 2 molarities and 2 volumes. It's also important for you to note that the unit for volume doesn't have to be in liters. Your V1 and your V2 just have to be in the same unit. So let's look at 3 examples. I think these are easy if you can just find the word of. If you find the word of, that's going to make your connection with your M1 and V1. So I know that 6 molar is my M1 and 250 is my V1. That tells me that my other given, which is 18 molar, is my M2, and I must be looking for my V2. So I look on page 3 of my reference table, and lo and behold, we have M1V1 equals M2V2, and then you just have to plug in your numbers. You want to solve for X. So to solve for X here, we're going to divide by 18 on both sides. That cancels it out, so I'm equaling X. When I plug this into my calculator, I would get 83. If I look at my units, molarity divided by molarity will cancel, leaving us with milliliters as our unit for volume. Let's look at number 2. So find the word of. That connects your M1 and your V1. So we can label those. The 12 molar would be our M2, and we're again looking for V2. So you look on page 3, you plug in your numbers. We want to solve for X, which means we're going to divide by 12 molar. That cancels the 12 molar on this side. And then molarity can cancel on this side. So our answer is going to be in milliliters. So when we multiply and divide, we get 17 milliliters. Now you're not always going to be solving for V2. So let's look at one more problem. Find the word of. That will connect your M1 and your V1. That tells us 125 milliliters is our V2, and what molarity means we're solving for our M2. Page 3 gives us our formula. We plug our values. We're going to divide by 125 so that we can get X by itself. That'll cancel out 125. Our milliliters cancel, leaving us with molarity as our unit. So we multiply, divide, and we get 3.0 molar. Now I've included the 0.0 to make that two significant figures. Make sure that you reach out to me on Remind, email, or Microsoft Teams if you have any questions.